going to cover 4.2, which is writing equations in point slope form. The reason why we need this is the problems that we've done so far, we've been given the y-intercept. We've been able to calculate the slope, and we've been given the y-intercept either on a graph or through a point where x is 0. But oftentimes we're not going to be given the y-intercept, so we need another method to writing an equation of a line. Slope-intercept form. Hopefully you have this memorized by now, but it's y equals mx plus b, where m is the slope and b is the y-intercept. Slope formula. We can calculate the slope from 2 points by finding the change in y over the change in x, or calculating the rise over run. And this is, again, from 2 points. So x1, y1, and x2, y2. So we would just substitute these values into the formula and calculate the slope. The new formula that we're going to learn is point slope formula, and it's kind of like a gateway to getting to our equation of a line. So the point slope formula is y minus y1 equals m times x minus x1. So make sure the x minus x1 is in parentheses, and x1 and y1 is an ordered pair that lies on the line. That is on the line. So again, you might see some similarities between this and y equals mx plus b. It's because typically what we usually use point slope form for is to eventually change it to y equals mx plus b. But the first couple of examples, we won't be doing that quite yet. So what we need in order to use this formula is the slope. We need m, and then we need an ordered pair, this x1, y1, and those will be actual values. So first example, we're going to write an equation of a line in point slope form. So on your homework, it's going to be really important that you pay attention to the instructions and what form it's asking you for. If it says point slope form, then our final answer will not have y by itself. So point slope form, let's start by writing that out. And just like how I mentioned doing this for the slope formula and for y equals mx plus b, for all of these, we want to make sure that we're writing out the form so that we can memorize it quicker. So your slope, your m, is 1/4. They give that to us in the problem. It passes through the point, -8, 3, and has a slope of 1/4. Then our point, our x1, is -8, and our y1 is 3. Don't mix those up. Remember, the x always comes first. So then we're going to substitute those values into point slope form. y1 is 3. M is 1/4, and x1 is -8. So be careful. The formula has a minus sign, and x1 is -8. So we'll have x minus -8. We should simplify that a little bit. So remember, point slope form, if it says that, we are not, and you might want to write this down, we are not isolating y if it says point slope form. So all I'm going to do actually is I'm going to make the minus minus a plus. 1/4 x plus 8. And we're going to leave our answer just like that. And that is point slope form. It looks like this, where x1 is a number, y1 is a number, and m is a number. So really all that we're doing with maybe a little bit of simplification if we have a double negative sign is, we're just plugging in these values. And then for the most part, we're going to be done. So let's practice that again. We're going to write an equation in point slope form of the line that passes through this point and has a slope of -3. So start by writing point slope form, stating what m and b are. So, or not b, m and your point. So m is -3, x1 is 2, y1 is -1. And then subbing those in. -2. And I'll just change the double negative to a plus. It might seem bizarre maybe that we're not distributing or we're not, getting the y by itself, but if it says point slope form, remember we're not isolating y. But if it says slope intercept form, like this problem does, then we are isolating y. So it's going to start very similar, or it's going to look very similar to our previous problem, at least initially, where we state what m and b are. Or not b, I keep saying b. We state what m and our what x1 and y1 are, and we write our point slope formula. The difference comes at the end. So far, this is just like what we've done in the previous two examples. The point is 4, 9. The slope is -1/2. So let's substitute those values in. So y minus 9 equals -1/2 x minus 4 times x minus 4. So in the previous problems, we would stop here. But since it says slope intercept form, and just as a reminder, that's y equals mx plus b. That means that we need to change the way that this looks. So by simplifying it and isolating y. So we'll want to distribute the -1/2. So that's -1/2 x, and -1/2 times -4 is +2. I'm still seeing a lot of mistakes when it comes to multiplying fractions and integers, and then anytime that we have a sign change. So multiplying a negative times a negative or a negative times a positive. We're not being really careful with that, or some of us are not being really careful with that. Just make sure that you are just aware of that, because if I change this to a -2, that changes my whole problem. Even though it's a small mistake, my answer would be incorrect. So that should be a +2. Anyway. Last step is to add 9 to both sides because we need to get that y isolated. And so once I do that, I have y equals -1/2 x plus 11. And that is my answer in slope-intercept form. So again, see the difference. It's asking us for our final answer in slope-intercept form versus in this one, it was point slope form. And point slope form looks slightly different, even though it's still a line. The final answer is going to look slightly different than in slope intercept form. The last problem that we'll look at in this video is the graph problem. We will do part B eventually, but I'll save that for another video. So if you're given a graph, for all these problems, we're starting with point slope because we're not really given the y-intercept. Now, you might see the y-intercept on this graph, but that doesn't explicitly tell us what it is. So we're going to use the points that they give us. So -2, -6, and 4, 6. So we need to calculate the slope first, and we can do that by just counting the rise over run. Now we have to be careful because it looks like this graph is counting by 2s. So really, I'm going from this point, I'm going up 2, 4, 6, 8, 10, 12. So this is up 12. And to the right, 2, 4, 6. To the right, 2. So my m is positive 12 over 2, which simplifies down to, oh, that's not 2, 2, 4, 6. That meant 6. Sorry. That's I was thinking about what the slope is, not how much I was counting. So again, the slope, the run is at not 2, it's 6. So 2, 4, 6. And so my slope is 12 over 6, which simplifies to 2. So once I know what my slope is, I'm going to use one of the points. Now I know they gave us 2 points, but I'm going to use one of the points. It does not matter which point you use. I'm going to use the 4, 6 point just because I like it when the numbers aren't negative. If I don't have to deal with negative numbers, I will usually choose not to. Now, if you decided to use -2, -6 as your x1 and y1, you would end up with the same equation. And I will show you that in a moment, but you only really have to use one point. So my m is 2, my x1 is 4, my y1 is 6. So I'm going to use that to substitute the values. Y1 is 6, m is 2. Oh, and I just realized, of course, I made a big mistake up here. That should say x1 or x minus x1. I'm getting ahead of myself. So make sure you fix that. That was not right what I had up there earlier. So x minus 4. Distribute the 2 because we want to write it in slope-intercept form, so simplify it. Y minus 6 equals 2x minus 8, and then add 6. So then y equals 2x minus 2. So if I were to use note, this is optional. This is still for part A. If I use -2, -6 instead, so my slope is still 2 no matter what, but now I'm going to let this one be my x1, y1. So y minus -6 equals 2, x minus -2. So these become pluses. So I have y plus 6 is equal to 2x plus 4, and then subtract 6. So you end up with the same equation of a line, even though you plugged in a different point. Okay. So just choose one of these points. You do not need to calculate it 2 separate times.